now we are moving on to our next speaker, who is going to be Michael Leicht from FRC team 1403, and he has one subject called Cooking with STEM, which should be a lot of fun. He is joining right now, I believe. Hi there.
Hello.
Are you receiving me?
Yeah, can you hear me?
Yeah, loud and clear.
All right, give me rename. Sorry, let me just rechange my name. Okay. So I share my screen and then we're ready to go?
Yeah, that should be about it.
Okay. All right. Good there?
Yeah, it's there. Thank you. Go ahead.
Okay, all right. Hello, everyone. I'm Michael Leicht, I'm a mentor of 1403. Today, I'm going to be talking, Cougar cooking is what we call it on our team, but cooking with STEM. So a little bit of background information. I'm an FRC mentor for 10 plus years. I currently work at Beeler of America in New Jersey as a process engineer. I was spent 4 years as a student on FRC team 1403. I'm a home chef, kind of amateur chef, but I like to cook on the weekends and try cooking different things. So I'm able to take that STEM and science stuff and meld it in with cooking. Engineers, just, when I was in FRC, I just thought engineers build robots. And thinking about it, first is more than just robots. If you take the science, for the inspiration of science and technology, and I think cooking is a great topic to talk about that. So why are we talking about cooking? I think one thing is cooking is science. Alton Brown's a celebrity chef, and he got me into cooking in the beginning with like a baked mac and cheese recipe that kind of started from there. But two quotes he has is everything in food is science, and the only subjective part is when you eat it. And then the last one is the kitchen is a laboratory, and everything that happens there has to do with science. I think that last one's really important to say. You can break down a kitchen, and yeah, it can be artistic in how you plate certain things, but when you break it down, a lot of science. Cooking is STEM. Cooking is biology, the study of living things. Big into chemistry, the study of matter. Kind of the picture there is the Maillard reaction of when you are browning trying to get a crust on a steak. The Maillard reaction, where it takes your sugars and amino acids with the reaction to heat, will create new flavors, different flavors for that, and where that kind of hits your taste receptors is a lot of science there. And then the engineering, what materials are you using, how are you transferring heat to certain things, and a lot of engineering principles can be explained of maybe why you're burning things compared to evenly cooking stuff at certain temperatures. But talk a little bit into that. An overview into this presentation, starting with safety. Safety is important. Safety with cooking, and then kind of some tools and talking about what tools are important with cooking, and then break down 3 different meals and how you can vary certain things, and there are certain properties of these meals, and they'll yield different results. So disclaimer with this presentation, it's not how to cook, but how to be inspired. How to be inspired by STEM and food. There's a different, besides just robotics, there's all these food sciences and things that you can look into to be inspired by. It just doesn't have to be, oh, I'm going to go into robots. So starting, please have a parent or adult present when you're cooking. If you're a minor, please, because there's a lot of dangers in cooking. First is if you're handling a knife, you can cut yourself, or a couple other tools. You're peeling a vegetable, or grating cheese, you can cut and hurt yourself, burn yourself. There's a lot of, you have a lot of heat, high heat too sometimes, that can burn, your hands, or, hot food, or even chemical burns, depending on what you're dealing with. And then another, damaging things, you have, you can burn your house down if you're not careful, or if you drop something, it can land on your foot, or hot oil splatters, and if you're not wearing pants, that could get onto your legs and burn your legs. And then the other important thing is food safety, is eating raw meats or other products that need to be food safe first, is something that is in to consider. You need to consider. It's taking temperatures of meat to make sure you're past the sterilization point. So some tools and equipment for cooking. Just a little diagram here of all the different kind of tools: measuring cups, butter dish, napkins, plate, casserole dish, cooker, fork, kitchen shears, chef's knife, cleaver. Those are two different knives. Whisk. So these are some different things that we can use in the kitchen. First thing, and kind of the one big important thing, is knives. And we have a couple different knives here. In a knife set you would get, you have a honing steel at the top. Then that's to kind of straighten your edge, so you have a nice kind of sharp knife between getting it professionally sharpened. Then you have a chef's knife, which is your multi-purpose utility knife for chopping vegetables, fruits, meats, kind of, can get in and give big cuts. Bread knife has a serrated edge, so it's for the crust, to serrate the crust, which will, cut the bread a lot better than trying to use a chef's knife and smushing the bread. Then you go into kind of some smaller knives with a paring knife. If you're trying to cut cut the top off a strawberry, a chef's knife won't be that big, because it, will be big and bulky compared to a paring knife, which will give you a little bit more precision to cutting. And then steak knives for cutting meat during a meal, that will do better than a butter knife that you normally have at a table. And then kitchen shears. These are important for cutting vegetables, or they're heavier duty than kind of your normal scissors that you cut paper with. These will cut animals up. If you're trying to cut the backbone out of a chicken and preparing a whole chicken, that's what you can use those things. Use the kitchen scissors for. Things to consider with this, once what I was talking about was the length of the blade. How easy is it to handle? How you hold the knife is very important as well. You can hold it by the handle and kind of have a rough chopping motion, but then you kind of see some chefs that take it just above the handle and will hold, will pinch it and have the, better precision in cutting. So there's some technique there. And then, like, the material properties of the knife blade. So this goes into some engineering with your material science. Not all steel is the same. You think, oh, well, just carbon steel or stainless steel and that's it. No, it can break down to different hardnesses in your steel, and how much of your elements are in the steel to create that, to create your mechanical compound, your mechanical properties in it. And then just kind of a quick, view here is you have all these different steel hardnesses. And then from that, you can look at each steel will have different properties for ease of sharpening, the toughness of it, the corrosion resistance, and edge retention. These are, the four major kind of properties that, if you're making a knife, these are something you want to think about, and how they work, and what will give you different results depending on what you're trying to cut or process. So there's heavy material science in just a knife. It's, so there's a lot of different topics. not just, oh, it's cooking and that's it. There's, you know, a bunch of them. So now looking at pots and pans, if you're, you know, what's the difference between a pot and a pan? So your sauce pot is a smaller diameter, taller sidewalls, and then that's for if you're making sauces, as it's in the name. You want to gently bring it to a simmer. You don't want to add too much high heat and burn the bottom of your sauce because of the smaller diameter. It's more for kind of letting flavors meld together over a long simmer in your saucepan. So you can add a small amount of heat compared to a fry pan where you have a larger surface and a larger diameter. That will, you know, you want to add a lot of high heat and, you know, have a Maillard reaction with maybe browning the outside of the chicken. And then thinking of your materials, can you place these if you wanted to brown the chicken, but it's not fully up to temperature and it's not safe to eat yet? You know, can you finish it baking this in the oven? With the examples I have there, you have plastic, which wouldn't do fairly well in an oven at baking at like 375, where you'd probably want a full stainless steel fry pan that you could finish baking your chicken maybe in the, you know, the oven. So there's two different things. If you're looking just now from kind of an engineering standpoint, you have two different shapes. You have a smaller diameter but taller, and how much heat are you affecting compared to a larger diameter where you can apply more heat to the surface area, and you know the different benefits in cooking. So as you can see here, the heat transfer and how long does it take to heat up a pan, you know, what your how your water maybe comes to a boil, and you know, if you're cooking pasta or something, and then material properties of cast iron versus stainless steel. Yes, they're, you know, they're two different materials, and what material properties are you concerned about when cooking? You may want to be like, I want to have something that retains a lot of heat. So when I put something on you put whatever you're cooking onto that pan, the heat just doesn't die away, and then it doesn't, you know, give you a solid amount of heat. So this is things you can look at, and if you want to get really technical and you know, do finite element analysis on heat transfer with this, as you can see in the corner there, and how that, you know, picking out what you're looking for with your cooking, with your, you know, pots or pans, non-stick versus, you know, like a cast iron isn't a non-stick, but the way you treat that so it doesn't rust, and go from there. Some other tools to think about: thermometer, so taking temperatures. What's the internal temperature of you know, a piece of chicken? If it's above 165, you're set. If it's below, you know, it's maybe needs more time. Timer, if you put something in the oven to bake, how long does that take? If it goes, you know, there's a certain time where it's like, if it takes too long, you can burn it, or it's not enough time, it's not done yet. There's that fine line needs to go across. You have tongs, spatula, oven mitts, kind of if you're taking something out of the oven, you know, safety there of high heat and protecting yourself so you don't burn. Cutting boards, protecting your kitchen counter. Colander for straining foods. Whisk, and then measuring cups. Depending on what you're cooking, if you're baking, measuring cups and spoons are very important to get your proportions right of how much wet ingredients and dry ingredients are mixed together to create a batter. If you're kind of cooking with herbs and spices and adding them at certain random times, that may not be as important, but still ratios of how much you add to get, you know, a repeatable product or a repeatable recipe down. Vegetable peeler, you know, pizza cutter, can opener, graters, the different textures of what you're cooking. If you're with garlic, if you have, you know, a clove of garlic, do you want little bits of garlic, or do you want like a paste of garlic where you'd use a grater or a garlic crusher compared to chopping that garlic up? And a juicer. So there's a lot of different tools and a lot of different things needed to how you process your ingredients to yield the end result. So moving on to breakfast, eggs, cooking eggs is kind of a staple for, most of my breakfasts. Cooking a chicken egg. So how do you cook it? Where does it come from? Breaking down the parts of an egg. So you have the yolk is the whites or the yellow center. The egg whites are the around the yolk. And then you have the shell, which is, calcium carbonate, which is just chalk. But it creates that shell to protect everything. Some things to think about that maybe, take a step back instead of, the chemical makeup of it, but let's look at the environmental impact maybe of where did these eggs come from? Are they locally sourced? Are they farm raised? Is it just a bunch of chickens in a pen, in a processing plant? What is the impact of these eggs and how are the chickens treated? This is another kind of environmental science and that side of it. Have chickens changed over time, over the years? Have we manipulated chickens to lay more eggs? And then where does it, are you getting it from a local farmer? Do you have your own chickens in your property, or you get it from a neighbor? But things to think about with it. How is it, are these things you care about, or you just care, I'm going to go to the store and get a dozen eggs and make breakfast? So some things to think about. And then cooking. So the chemistry of the egg and the eggshell, you have your chemical properties of it. And when you're cooking an egg, the proteins denature, in which it unwinds amino acid chains. And then adding heat to the egg will cause those unwound chains to create new bonds, which coagulate solids, which then makes your eggs edible. The heat will also kill bacteria to make your food safe, but you are coagulating these proteins into an edible source or edible substance. And then, so how do you do that? What's your method and what mode of heat are you adding? So we have different styles of cooking. You have a hard-boiled egg, you have scrambled eggs, you have a fried egg and poached egg. We're gonna look at hard-boiled and scrambled eggs. So two different modes of applying the heat. So for the first one, the hard-boiled egg, you place eggs in water for a set temperature and a set time. What happens if you change the time or temperature is something you can play around with. So to kind of cook a hard-boiled egg, you bring water up to a boil. You place the egg into the pot, cover and remove from heat. And the image I have there, as you can see, depicts what happens to the egg over a set time. So you can start with the egg that has, just the raw egg at 0. And then as you, increase time, the egg goes from, the egg whites start to solidify and the yolk kind of stays runny a little bit in the middle because of the heat transfer coming in. And, 9-11 minutes is usually where you set it, take the eggs out depending on what you're looking for. If you're doing a soft boiled egg, you take it out at like maybe 3 minutes to have a runnier yolk. But then if you get past 12-13 minutes, the egg whites get rubbery and the yolk gets chalky and it's overcooked. So it's kind of, and then once you have your set time, removing the eggs from the pot and placing them in an ice bath to stop cooking them. So this is something you can play around with and see what happens with the time and temperature. If you lowered the temperature from boiling to 190 or 170 Fahrenheit, what would happen, and play around with that. So then the next thing is with scrambled eggs, instead of placing the eggs in boiling water, you're applying direct heat in a matter of in a frying pan or in a boiler. So you have 3 styles of scrambled eggs. You have the American style, which are large curds. That's on the right. So that would be right here. You have the French style, which is in the middle, and the English style, which is on the left. And the American style is you heat a pan, throw the eggs in, scramble the eggs, throw them into the pan, and move them periodically. This will create large curds of the eggs, the scrambled eggs. You know, kind of what you see in a hotel breakfast, standard eggs there. And then the French style uses a pot of boiling water and then a bowl on top of that boiling water, and uses the steam from the boiling water to apply heat, and then it's stirred kind of constantly to create this, to slowly bring them up and create a creamier, very, less curds in there, less, bigger formed curds, to create a creamier texture of scrambled eggs. It's just one way of, that style of doing it. And then the English version is kind of a mix of the American and the French. It doesn't use the steam to heat it. It uses, stovetop burner, and you kind of take it off and stir constantly to break down having such large clumps of eggs. So it all depends on how you prefer your eggs and how much time you want to put in. If it's quick, American style works. If you got some time, French or English style, they're delicious. It definitely is different if you're used to the American style and you go to an English style. It's a lot creamier and it's not as dry sometimes, depending how long you cook them for. Going now into lunch, our team, we enjoy our mac and cheese, so went into how to kind of cook some mac and cheese here. And what you're looking at, you have two kind of versions of it. You have a baked or a box mac and cheese, and then you have baked mac and cheese and what you're looking for. So with the box, it's a shelf-stable product, something that's in the supermarket. You have your cheese sauce mix, which is, what you have contained there. And then, it's a factory-produced product. It's, and it's just a consumable product. So kind of looking at it like, where's the cheese for this? And what is it made of? You have some cheese parts. So with that, wondering, well, if that's what's in this mac and cheese, how does cheese get made? And here is the cheese process. You have raw milk, depending on what animal the milk is from. Most of it, sometimes you have goat cheese, and then most of it is cow cheese, where depending on the industrialized way they make it, if it is in a big factory and it's making block cheese, they usually pasteurize it, filter it. And then you have kind of like a rustic local cheese maker where you have the filtration of it, and then they add enzymes and kind of a fermentation side of things where it coagulates the milk proteins out of solution, where you cut it and it starts to separate the whey and the curds. The whey is the milk protein liquid, and the curds are the solids. So the curds get separated from the whey. The whey can be used for other products, but then they take the curds, they mill it up, add salt, and at that point you have cheese curds, fresh, or cottage cheese, cream cheese, and like fresh there, or they place it, compact it into molds and age it for a time being there, and ripen it, and it depends on what you're looking for. This is kind of a cheddar. You also have different other kind of microorganisms in different other cheeses, like blue cheese. The blue little bits are mold, and it's a controlled, kind of a controlled rot with that, and controlling the aspects of it is another, scientific research that people are looking into, and how you can get different kinds of cheeses and control it and get great flavors from it depending on how you age it. Or and even back into I was on a cheese tour in Vermont, and because of safety concerns in their cheese cave, they had a robot take cheese off the rack, apply brushes to the top, flip the cheese over, brush the bottom, and then would put the cheese back on the rack. So they, instead of having people do that, where ammonia is present in that scenario where they have to limit the amount of time people are in that location, they had a robot do it. So there's a bunch of different applications to the cheese industry, not just, scientific research on, the lab testing on cheese, but, the upkeep of it, and engineering safety factors into that. So once we have cheese, you're going to make a bechamel sauce where you're going to take butter and flour, make a simple roux, cook the flour, taste out of the flour, start to add milk. This starts to create a creamier sauce. This will help emulsify the cheese into a sauce. If you were just to add cheese straight into pasta, you get a lumpy mess where it doesn't allow the cheese to fully melt and create this kind of, velvety sauce. So you would make that bechamel sauce, you'd bake your pasta, put the two together. One little bit of things to consider is your shredded cheese versus your block cheese. Shredded cheese is convenient because you're not sitting there shredding cheese, but another thing is they put powdered cellulose to prevent caking, or to make it shelf stable, keep it drier, but it doesn't really work when you're making a mac and cheese. So it is convenient, and I know I've used it a bunch of times to save time, is just add shredded cheese, but it changes the consistency, and it's just based on what they the chemical components to make something shelf stable. And then you add this and bake it in the oven. So with that, and you can get different flavors and profiles and tastes. Not all cheese is the same. You can have cheddar, pepper jack, blue cheese. I mean, there's a massive amount of different cheeses out there. Brie, triple cream, and goes into that. And you can mix different cheeses together to get different flavors. I know when I make mac and cheese, I like to throw sharp white cheddar, and then to add a little bit of like earthy funkiness, a little bit of blue cheese in there, to combat the nice sharp saltiness of the white cheddar, to give a different flavor profile compared to kind of just like yellow American cheese on mac and cheese, to get different flavors. You can play with different shapes, elbows, bow ties, spirals. Even I found one where they're like little rackets, like tennis rackets. I use sauce and spices. You can add buffalo sauce to it. You can add, mustard powder is always a staple into the cheese sauce, and then toppings. Breadcrumbs are usually a traditional, but I've added crunchy Cheetos to add more cheese, or chips. It's kind of whatever you're feeling or whatever you want to experiment with that day. And bake. Just be careful with the toppings; they don't burn if they're in the oven too long. Usually bake the mac and cheese for a little bit and then add those on top. And then kind of a staple on our team, and pizza. Pizza is usually every lunch every Saturday during build season. So go into the how is pizza made? What does it go into there? You have a pizza dough, the flour, the water, salt, and yeast. Then you have the tomato sauce, and then mozzarella cheese. Toppings are optional, but traditional, just cheese pizza is what we're going to talk about. So let's start with the dough and flour. I mean, the big component of flour is so in your grocery store, you have kind of two flours. You have a all-purpose flour and a bread flour. Knowing the difference between those is, will help you, and why are there two different ones. The bread flour is, to start off, has higher protein content. Then all-purpose flour has a lower protein content. So this will lead to more stability, form, and rise in the dough, allowing to lift and hold its shape. That high protein. The protein content is kind of your gluten content, which will, as you need, will develop these gluten strains, and that will allow for the dough to stretch a little bit, which will get you, kind of those pockets of, as you can see here, those air pockets in your pizza. And then all-purpose flour is more for like cookies and cake, kind of a denser, lighter, lighter breads for it. But if you're looking for this airy bit or airy dough, you want something with a little bit more higher protein content. Now looking at the kind of the chemistry of bread making, which is essentially the pizza dough, you have your proteins that adding water will create these gluten, these protein networks that you build up these gluten. And then you can, another thing when we talked about salt in the dough recipe, that slows down fermentation. And then, so you have your flour, your water, the salts for a little bit of flavoring. And then, you have the last one, which is a Saccharomyces, which is yeast, that will chew on the glucose, process the glucose molecules, and then create ethyl alcohol, which gets baked off. And then you have your carbon dioxide, which will get trapped into your gluten matrix and provide that, the leavening of your dough. So this is, you have a single cell microorganism that will add, flavor too. It adds some flavor to it. If you were kind of in a pinch, there's other ways of adding the airiness, like baking soda will create some CO2, but for that, for a better flavor, the yeast is going to when it's metabolizing the sugar into, the CO2 is what the end product is. You also have a bunch of other flavor compounds that come out from the fermentation process that add to the overall flavor of the dough. So then looking at, okay, you have your dough, you have your dough rolled out, you have your sauce on it. Next thing is, I bake pizza from home, and it's not as the, pizzeria down the street. It's not the same. It's a little more doughy. It's a little like undercooked. And that has to do with, what their oven is compared to what your oven is, unless you have like a pizza stone or you have a dedicated pizza oven. In the industrial pizza ovens, there's special material that perform a couple tasks: storing heat. These stones or steel hold a lot of heat, and when you put the dough onto that surface, the heat will transfer into that, rapidly cooking the dough, and it will create your crust. So if you're wondering what if I make pizza at home in a pan, it's not a nice crust on the bottom, but kind of just this doughiness. It's figure out how much heat you're adding and what, is that pan. The pan's not hot, it's going into the oven that's probably 500 degrees. How quickly are you able to transfer heat on a conductive surface compared to convex or convection mode of heat transfer. So the conduction is going to transfer the heat into your pizza dough a lot quicker and create a crust. And then a little thing of dessert, chocolate chip cookies, a little simple recipe I was able to find online. But then looking at it is if you want to customize that cookie to be, oh, my cookies don't come out as chewy, or they're, cakey or crispy, there's some different things you can add or change in your recipe with this baking to, like, oh, I always want a chewy cookie. How do I get that? Well, add an egg yolk and use brown sugar, and that will, help out. Or, I want a crispier or cakey cookie. So different things to manipulate and bake and test and use the scientific method to change that up. And then if you're looking to do more, these are 3 kind of resources that I've used. Binging with Babish is a YouTube series. He does basics with Babish. He goes over, kind of the introductory steps in the basic series. And then binging, he uses TV, movies, video games, recipes from those to recreate those recipes, and they're real good. A good, Alton Brown and Good Eats is always a solid resource. He goes into the science of things. That got me into cooking. And then the Food Lab by Kenji Lopez Alt. I think it's like $50 on Amazon. It's like 300 pages, but it goes into the science and, better home cooking through science. He goes into, cooking chicken at a certain temperature. If you're cooking it at 150 and you hold it for a set time, that'll be just as effective and safe than cooking at 165. And the difference between that are, different cooking methods and what works through science, and not just, no, this is what I think worked and how I, worked. So that's one book I recommend if you're starting to cook or want to get more into cooking. And then my resources for this. Any questions?
Okay, thank you for your presentation so far. We have a couple of questions coming in.
Okay.
Number 1 is, how did you learn about the science behind cooking?
How did I learn the science behind it? Just making this presentation, I didn't really delve into more of like, I would cook and, I'd make pasta or dumplings or pizza and didn't really think about, why I'm doing certain things. And when I started looking into it, I'm like, oh, that makes sense. Or like, that's why I use all-purpose flour or bread flour. This is, and kind of answering a few questions in there to why I'm doing certain things instead of blindly just going through it, and helps, or if I'm cooking something, how, why would I burn eggs? I'm like, oh, the heat's too high, and think about it from a, scientific standpoint, then I'm just going to try cooking. So looking into that. Yeah,
well, it sounds fun. Yeah. And did being involved in FRC actually push you to learn more about cooking, or did you just like it beforehand?
I liked cooking. I kind of wanted to be a chef when I was younger. What made me want to do like this presentation stuff was talking with a couple of my students on my team. They were like, yeah, especially during quarantine where they're at home, they're like, yeah, I don't know how to cook, and I always wanted to cook. And it's like, oh, well, let's give them kind of a little life skill or teach them how to cook, or talk into thinking of how to cook. And that's kind of where this came from. But yeah, I've always liked cooking since, at holidays where we'd make, pierogies around Christmas time, or, other foods, just, yeah, always around cooking.
Yeah, it sounds like a lot of fun. I think that about wraps up this presentation. Do you have anything to add?
No. Thank you for hosting this. This was fun, and yeah, thanks.
Yeah, it sure was a lot of fun. Thank you very much for the presentation, and we'll be continuing with some intermission videos. Yeah, I wish you a good day for the rest, and
right.
Yeah, see you another time.
All right, thank you.
No problem. Bye.